Ladies and gentlemen, distinguished scientists, engineers, research scholars, and our honored guests, warm greetings and a very good morning to all. In the words of one of the foremost astrophysicists of the 20th century, Professor S. Chandrasekhar, in science, there is only one way to progress, by stepping into the unknown. AstroSat, India's first mission dedicated for astronomy, provides a giant leap into unraveling the mysteries of the cosmos. Today, we have gathered here not just to hold a conference, but to celebrate a legacy. A legacy of looking at the universe in multi-wavelength simultaneously, of exploring the nearest star, Proxima Centauri, to the farthest galaxies, white dwarfs to black holes. A legacy of discoveries and exciting results and a decade of enabling researchers worldwide. I'm Maria Ratlami, and it's a privilege to welcome you all to the Garden City of India, Bengaluru, a vibrant hub for space sciences, defense, biotech, and IT, for this 3-day international conference on AstroSat, a decade of AstroSat observations, science outcomes, and future prospects, organized by Rao Satellite Centre, Indian Space Research Organization. We are honored to have with us our esteemed dignitaries for the day. Dr. V. Narayanan, Secretary, Department of Space, Chairman ISRO, has joined us virtually for this inaugural session. Sir, we are delighted and honored to have you with us today, and we warmly welcome you. We are also honored to have amongst us our dignitaries for the day, Shri A.S. Kiran Kumar, Chairman, EPIC Science Board and former Chairman ISRO, Shri M. Shankaran, Director, URSC, Dr. P.S. Goel, former Director, URSC, Dr. T.K. Alex, former Director, URSC, Professor P.C. Agrawal, First Principal Investigator, AstroSat, Dr. V. Koteshwar Rao, First Project Director, AstroSat, Dr. S. Sita, Principal Investigator, AstroSat, and Professor Dipankar Bhattacharya, Chairperson, Scientific Organizing Committee, and Sri Jaswinder Singh Khoral, Chairperson of the Organizing Committee. We welcome you all to this conference. Rao Satellite Centre has been at the forefront of designing and realizing some of India's most complex and critical satellite systems. Under the able leadership of Sri M. Shankaran, the Centre continues to scale new heights in advancing India's space program. I now invite Sri M. Shankaran, Director URSC, to the podium to deliver the welcome address.
Good morning, respected Chairman ISRO, respected senior members of India's science community, all my dear colleagues and former colleagues, students and dear friends. It gives me immense pleasure to invite you all for this milestone event of celebrating 10 years of AstroSat in orbit and delivering science. Welcome to this celebration and be part of the history of astronomical science through satellite technology. Let me begin with welcoming our Chairman ISRO, Secretary DOS, Dr. V. Narayanan, who had readily agreed to be part of this celebration and to give the inaugural talk. However, due to an exigency, he had to be out of town. In spite of that, he agreed to be available online and is participating in this celebration. Thank you very much, sir, for taking time out and joining us here. And I welcome you to this celebration of science. Welcome, sir. Shri Kiran Kumar sir doesn't require any introduction to any of the people who are here. Our beloved former chairman and chairman of the Apex Science Board, and who has been guiding many of us in not only this mission, in many of our day-to-day activities related to satellite building. He is an inspiration for all of us through his commitment and perseverance. He has inspired many of us, and it gives me great pleasure in welcoming you, sir, for this 10-year celebration of AstroSat. And we have a galaxy of the scientists over here. Let me start with our own Dr. P.S. Goyal, Dr. Alex. We have Dr. Koteshwar Rao, who have led the center, Rao Satellite Centre, then known as the ISRO Satellite Centre, and also in the case of Dr. Koteshwar Rao, the AstroSat project itself as project director. Let me welcome every one of you to this important milestone and celebration. Thank you for joining us today on this occasion. We have the most respected Professor P.C. Agarwal, the principal investigator for AstroSat. As lead of the three main instruments which have gone into this important and milestone spacecraft for Indian astronomy and space science. We are all indebted to you, sir, and your team, and many of your contemporaries and colleagues who have also participated as scientists and instrument and science people for the AstroSat payloads. I welcome you and all of them to this important milestone here. Welcome all of you, sir. It is a honor and privilege that you could grace this occasion. We also have our own serving ISRO leaders, starting from Professor Anil Bharadwaj, Director PRL. We have the Scientific Secretary here, Ganesh Pillai, and we also have a number of people. If I'm going to call out everybody by name, the entire morning session we can spend on that. So forgive me for not calling out everyone by your individual name. Please consider it as a personal invite for every one of you to welcome to you to this 3-day conference, which is more a celebration. Along with that celebration, we are also going to get a number of presentations, roughly about 80 parallel talks in 3 parallel sessions, some about 27 flash talks, couple of keynote addresses and 4 plenary talks, and a panel discussion and poster session. You name it, you have it all here. The next 3 days are going to be not only be reminiscences for the people who have been working on AstroSat for almost more than 25 years now, because the time when I was entering also, Alex sir was telling me also, 2000 was the year the approval for this mission came. So it is more than 25 years, even officially after the approval is given. So it will be not only listening to the scientific talks, but also lot of reminiscences and an occasion to inspire the younger members of this audience, who have to carry forward this legacy from all you stalwarts. And I am sure that this occasion will act as another instance where the younger generation of our astronomical science community gets inspired. Let me once again welcome every one of you for this conference. And if I'll be failing in my duty if I don't mention the two organizing committee chairman, Professor Deepankar, as well as Jaswinder. I will, as a host center, URSC's director, let me welcome all of you, your team, and all the volunteers also for this conference, so that we will have an outstanding 3-day program, which will not only be scientifically enriching, but also be refreshing through the interaction with the younger people. Thank you very much.
Thank you, sir, for that warm welcome and giving us a motivating start to the day. We now proceed to the inaugural address of the conference. Dr. V. Narayanan, Secretary, Department of Space and Chairman ISRO, has been instrumental in steering India's major space missions with a strong focus on self-reliance and innovation. Alongside his role in advancing India's space program, he is also a passionate advocate of science outreach, deeply committed to taking scientific knowledge and its outcomes to the common man. Sir, your esteemed presence has made this event more memorable, and we eagerly look forward to hearing from you. We request you to kindly deliver the inaugural address.
Very good morning to all of you. Most respected A.S. Kiran Kumar sir, former chairman ISRO and present Space Commission member, Dr. P.S. Goyal sir, former director of URSC and secretary Earth Science Department, Dr. Alex, former Space Commission member and of course former director of URSC, present director URSC, my close friend Mr. Sankaran, and Dr. Rajarajan, director VSSC, who is with me currently in Chennai, and Dr. Anil Bharadwaj, Dr. D.K. Singh, and my dear colleagues, and very important personalities like P.C. Agarwal, former PA of the AstroSat, Dr. Kodiswara Rao, the first project director who was laid the very strong foundation for this AstroSat spacecraft, Sri Surya Narayana Sarma, hope he is present there, and all my dear colleagues, students, and delegates from various institutes. Very, very good morning to all of you. It is really a befitting manner, a decade of AstroSat satellite, which is now also serving fantastically in the orbit. We are celebrating a 3-day function is organized to understand the outcome of the scientific outcome. 28 September 2015 is PSLV C-30 vehicle successfully placing the AstroSat. And at that point of time, nobody believed that it will work for 10 years like this. But today, 10 years, fantastically it is working. And almost 32 terabit of data, scientific data is already distributed to the scientific community. First of all, I have to thank Mr. Sankaran for mooting the idea of this celebration, bringing all the stakeholders together and organizing this very, very important function to really celebrate in a befitting manner. Now, we must remember that AstroSat was not merely a technical project, but a testament to Dr. Kasturirangan's foresight. At a time when India's space science was primarily focused only on Earth observation and communication, it was his unwavering conviction, along with his senior colleagues, that India must have its own eye in the sky to probe the deep mysteries of cosmos. The unique capability of simultaneous multi-wavelength observations was concept championed by Professor Kasturirangan. He integrated the diverse strengths of Indian academia and ISRO. At that point of time, I think the activities were really not integrated, and he was the first person who was responsible for integrating this activity, fostering a collaborative spirit. Based on that, today, if you look, a lot of accomplishments, achievements, and lot of benefits we are getting. The remarkable of this project led from the forefront by a couple of very key people. Our former scientific secretary, scientific secretary is a very, very key position in ISRO setup. Of course, ISRO chairman secretary is there, but then the entire activity is really guided, rolled by scientific secretary, former scientific secretary, and the first project director, Dr. V. Kodiswara Rao. Really, I understand he has, I know of late his capability, his leadership role, very strong foundation he has given. And subsequently, it was successfully accomplished by the project director, Surya Narayana Sarma. And today, we are really harvesting the outcome of that 10 years successfully working the orbit, giving lot of scientific achievements and lot of data. It is highly inspiring to think that AstroSat is the baby of several institutes, not only ISRO. The major institutions that have been instrumental in the inception and realization of AstroSat include different centers of ISRO, Tata Institute of Fundamental Research, IIA, Inter-University Center for Astronomy and Astrophysics, Raman Research Institute, PRL, Canadian Space Agency, University of Leicester, and University of Calgary. I think at that point of time, 1996, when this project was really conceived, and something around 30 years back, a person conceiving this satellite, bringing scientific community, academia, and ISRO centers and other countries into the fold and making a satellite. What a fantastic thing which is done at that point of time. And today, the younger generation, we have done a small thing towards this. In Indian Space Research Organization or the Department of Space, the major activities were in the area of launch vehicles, satellites, application, and infrastructure. When Dr. Kiran Kumar sir was the chairman ISRO, he brought the concept of the Project Management Council organizing, because this activity is not done in one center. For example, take satellite activity. A lot of ISRO centers are involved in the activity. Same way, launch vehicle, it is not only done by VSSC, it is done by so many centers. So he brought a concept, Project Management Council, synchronizing and putting together all the activities. 4 project management councils he rolled out. Project Management Council for launch vehicle and related activities, Project Management Council for space infrastructure, basically satellite related activities, and infrastructure development and application. And when Dr. Sivan was the chairman, of course, the human space flight program came, and he brought one more vertical, human space flight vertical. And understanding the importance of science and astronomy to give major thrust. This year, almost when the AstroSat was completing 10 years, we formed the next important vertical, Project Management Council, Space, Science, and Astronomy, to give a befitting respect for the 10 years of completion of AstroSat. This Project Management Council was formed, and one of our senior colleague, Anil Bharadwaj, is really giving leadership role from the front. And we are really expecting lot of outcome from this Management Council, giving direction and guideline to give great thrust and push for the science and astronomy area. Now, when you look at AstroSat, please understand today conceiving a satellite and building is very easy. But at that point of time, 2010-15 time frame, conceiving itself is a very tricky job. First of all, let me thank, congratulate, compliment all the people, starting from the then project director to all the PIs, all the project executives, all the engineers, the then directors of the centers, who have really done great job in realizing the satellite and successfully placing the orbit using the PSLV C-30 launch vehicle. Surely, at this juncture, we have to also thank the launch vehicle community, who have really given the fantastic launcher, PSLV C-30, to placing the satellite in the orbit. Today, when you look back, almost 33 terabit data. From that, what I understand is something around 550 plus journal publication has come out only through the discovery of this AstroSat. And almost more than 40 PhD theses have come out from these activities. A major scientific breakthrough was the detection of 4 ultraviolet photons from galaxy located 9.3 billion light years away. What a great achievement by the organization which started just 63 years back. And this mission also has contributed vital data for understanding black hole evolution. And today, when I look back, 10 scientific missions we have accomplished. The first scientific mission, Aryabhatta, 1975, I think Dr. Goyal sir and all the people who are there, probably they have put their hand very strongly. From Aryabhatta in 1975 to Strauss, Chandrayaan 1, URSC, Mars Orbiter Mission, AstroSat, up to 2015, 2075 to 2015, in 40 years, 6 science missions. And last 10 years, 4 more important science missions are accomplished. Chandrayaan 2, Chandrayaan 3, Aditya L1, XPOSat. And we are putting strong foundations for some more scientific missions, like exoplanet. This is one of the important activity what we are going to take up. In fact, the project report is going to be sent for final approval. And India is also setting up a 6-meter terahertz telescope at Handley to bridge a critical longitudinal gap in the global network. This will act as a precursor for space-based terahertz missions. Our roadmap also includes astronomy from the moon. And lot of activities are really lined up. Now, Honorable Prime Minister of India, Narendra Modi ji, he has clearly given a direction and a vision to be taken forward by the space activities up to 2047. When we are talking about Bharat Antariksh Station to be built by 2035 timeframe, the first module already we have got the project approval, and we are going to accomplish that by 2028. Surely, this also will serve as a permanent in-orbit laboratory for UV and X-ray observation of galactic and extragalactic sources. And long-term plans include a large aperture multi-wavelength space telescope to maintain our leadership in the global arena. And we are also having approved projects and programs like Chandrayaan 4, Chandrayaan 5, and Venus Orbiter Mission. And all these activities are going to be there. And when you talk about a country becoming a developed country stature, yes, we have used F is equal to ma equations discovered by some other country, but it is also our responsibility as a responsible and developed nation to contribute significantly in the area of science, not only technology, in the area of science. It is towards that the AstroSat is a shining example, a satellite working continuously for 10 years, bringing out a lot of scientific data for the scientific community. Chandrayaan 3, you all know it was a successful mission. Everybody knows it landed successfully, but I don't know how many of the people in the public knows its discoveries. 8 minerals were discovered, and we have discovered a lot of things, including seismic activity, electron cloud, and all these things has to come out properly. I have given some small request and guideline to my team members to bring out 100 textbooks before this year end. That is the target we are setting. Even if you get 75% mark, I will be very, very happy. I am sure the team is already motivated and they are in the process. And on this occasion, this is an occasion to thank the people who have contributed. This is the occasion to motivate the next generation by explaining what is done, what is the accomplishments done. And it is in that context, truly, this conference, 3 days conference, that to participation of great leaders like Professor Goyal, Mr. Kiran Kumar, our Kiran Kumar sir, and Dr. Alex, this type of people presence along with the key PIs is going to really contribute and motivate the younger generation. It is going to really give a lot of advantage towards that. Now, before I conclude, let me make 1 or 2 points. Last year, we have made very important, successful missions. The NSR mission, Even yesterday, it has given a lot of fantastic data. NSR mission was successfully accomplished. Then there is a 4,400 kg communication satellite we have lifted from Indian soil and placed in the GTO. Right now, the satellite is moved to the geostationary orbit, perfectly working and for the strategic application. And the heaviest satellite ever lifted from India was accomplished on December 24th, a Bluebird satellite. That too, 50 years back, for India, for demonstrating the application, we got the satellite, ATS-6 satellite signal from USA. For that country, we have accomplished the commercial mission last December. Of course, we also had a couple of lessons to be learned. Some of the mission we could not accomplish, but I am 100% sure the ISRO community is famous for learning the lesson from setbacks and bounce back at the earliest opportunity. And I don't have any doubt the team will do that and will come back at the earliest opportunity. No doubt, last year was a year of achievements and accomplishments, including docking experiments and rolling out data from Aditya alone, lot of things, and something around 250 scientific R&D activities we have successfully accomplished. Now, on this day, once again, let me thank the people who have assembled here, and I am sure ISRO and the space communities of India is going to contribute in a very big way towards the scientific discoveries and achievements. And let me thank all the senior people who are participating in this. And I really apologize, I could not participate directly, but I assure by evening I will reach and I will meet all of you. I will be with you in the evening and maybe day after tomorrow also. Thank you. Jai Hind.
Thank you, sir, for the inspiring and encouraging words and giving us glimpses of the journey of AstroSat and the exciting path ahead. It's our pleasure to invite our dignitaries for the day to take their seats on the dais. We now extend a hearty welcome to our dignitaries in the language of flowers, a symbol of respect, growth, and our commitment to nurturing science and nature. We welcome Shri A.S. Kiran Kumar, Chairman, EPEC Science Board and former Chairman ISRO. I request Srimati M.C. Ramadevi to present the sapling. We extend a warm welcome to Shri M. Shankaran, Director URSC. I request Srimati S. Kakati to present him with a sapling. I now invite Srimati Smriti Verma to welcome Dr. P.S. Goel, former Director URSC and former Secretary, Ministry of Earth Sciences, with a sapling. Next, I call upon stage Srimati Jayashri to welcome Dr. T.K. Alex, former Director URSC and former Chairman, Advisory Committee for Space, with a sapling. We welcome Professor P.C. Agrawal, First Principal Investigator, AstroSat. I request Dr. Girish V. to present him with a sapling. I now request Srimati Mahalakshmi to welcome Dr. V. Koteshwar Rao, First Project Director, AstroSat and former Scientific Secretary, with a sapling. I now invite Srimati Komala to welcome Dr. S. Sita, Principal Investigator, AstroSat, with a sapling. We now welcome Professor Dipankar Bhattacharya, Chairperson, Scientific Organizing Committee. I request Srimati Swapnil Singh to welcome him with a sapling. I request Sri Shivakumar Sahu to welcome Sri Jaswinder Singh Khoral, Chairperson, Organizing Committee, with a sapling. We are indeed fortunate to have amongst us one of the stalwarts of India's space program, Shri A.S. Kiran Kumar, former Chairman ISRO and Secretary Department of Space, under whose leadership India's first astronomical satellite, AstroSat, was launched, marking a major milestone and strengthening India's footprint in space astronomy. Sir, we are eager to listen to your words of wisdom and guidance. We request you, sir, to kindly address the gathering.
Good morning to all of you. Dr. Agarwal, Dr. Goel, Dr. Alex, Shankaran, and all the dignitaries on the dais, and all of you who have gathered here today to mark 10 years of successful operation of AstroSat. If you look at India's journey into space, it started using space technology for bringing in the necessary support that was required for the growth of the country at a time when, after many centuries of external rule, India was struggling to provide its food, shelter, and education to its citizens. There were great visionary scientists like Dr. Sarabhai who visualized this disruptive technology of going to space, how it can make a difference to a country like ours. So obviously, the use of space technology, India became only the first country to use it for civilian purposes, started using space technology for enabling communication, broadcasting, weather monitoring, all that. But then the great visionary scientists who started and were organizing the agency, like Dr. Sarabhai, Satish Dhawan, Professor Rao, Dr. Angan, and many others who followed, all of them were looking at how this technological capability of building satellites, taking it to space, and then for taking it to space, building launch vehicles, all of that. While we do this, we also need to make sure that we build a capability in the country of making use of space for observation beyond Earth also. Because as humanity keeps evolving itself, the need for exploring and understanding becomes a very essential component. The initial targets definitely are how to make sure that you do a comfortable living and you improve your survival on Earth. But then, when you start looking beyond that, what happens in the universe becomes such an important aspect. And ISRO, right from inception, has been looking at using of space technology for enabling the country to move ahead. So starting from the early days of 1960s, even the first experiment that was done was also laced with how to look at what is happening in upper atmosphere when initial sounding rockets were launched. But then gradually it built up its capability, and as has already been pointed out, for more than a quarter century, an activity which initiated in the country, bringing together a host of institutions across the country, because it is not just one agency which can do the task of building space technology for the development in the country. So you saw, starting from late 90s, great stalwarts looked at how can we make sure that India not only makes use of its technological capability for addressing the day-to-day problems, but also starts looking at beyond. And it is in this context, this particular gathering today, where probably people who have worked for more than 20, 25 years are present here. They are remembering how this activity developed. And the very fact that we are able to conduct an event like this reminds us that what is behind this development is an enormous task. And as India is now trying to move ahead, becoming Vikasit Bharat by 2047, 100 years of independence, where should the technological development of using space take us? And obviously, we all realize that people recognize you for your demonstrated capability and not for your claimed capabilities. And it is here that unless you keep abreast of what is happening contemporarily and then build your own skills and knowledge sets and then make use of it for not only showcasing to the others, but also go through the true purposes of exploration. Exploration of space with tools makes humanity understand not only itself, but also how to negotiate and navigate future. Today, the technological changes that are happening, whether it is quantum or artificial intelligence, all of that should remind you that it is at the center of it, it is your asli intelligence which is operating. And if you are capable of making use of it, all the technological tools you are going to build will make a better living space, not only for planet Earth, but for also the people understanding the universe itself. And in this context, the contribution of AstroSat has been phenomenal, because not only it has showcased that countries can look at building, making use of new technological, disruptive technologies and new avenues for enabling them to survive, but also look ahead. So let me take this opportunity to compliment the organizers of this program for bringing together all the people who participated at various levels, and not only that, showcasing to them what they had done, what it has produced. And we have here a lot of user community people who have made use of the data generated from this satellite. And it is also going to be there for quite some time to come. And it's only when all this data gets through the sieving and intellectual, you can say, churning, that we can make a better understanding of the universe and then continue our journey in this planet. Thank you very much. Wish you all a great 3 days.
Thank you, sir, for sharing your valuable insights on ISRO Space Science Program. Your perspective and experience truly enriched and inspired us all. Ladies and gentlemen, I now take the opportunity to invite Professor P.C. Agrawal, the first principal investigator of AstroSat and Professor Emeritus at TIFR, a pioneer of X-ray astronomy in India. Professor Prahlad Chandra Agrawal was honored with the prestigious COSPAR Harry Massey Award 2024 during the 45th Committee on Space Research Scientific Assembly in Busan, South Korea, becoming the first Indian to receive this Lifetime Achievement Award in space research. We invite you, sir, to walk us through the journey of AstroSat from concept to completion.
Thank you. At the outset, let me apologize that due to my severe handicap, I am not able to talk as coherently and as fluently as I used to. So please forgive me and understand that I have this difficulty. So having said that, let me say that I and my colleagues and entire scientific community in India is very greatly pleased and happy at the performance of AstroSat, and it has successfully completed 10 years of operations. Now, before I go, let me say that AstroSat has a big history behind its genesis and then realization. I described this in an article, Journey Through the Birth, Progress and Maturity of X-ray Astronomy. Now, my thoughts go back to 25 years ago, when the work in X-ray astronomy really started progressing in India. X-ray astronomy is a young science of astronomy, which was born only about 50 years ago, in 1962, when the first X-ray source, SCO-X1, was accidentally discovered by Dr. Riccardo Giacconi and his team in a rocket flight, which is meant to detect fluorescent X-rays from moon, but instead it stumbled upon the discovery of SCO-X1. Now, SCO-X1 was a fantastic object because when you look at it, later on look at the optical star with which it is a companion, it has a luminosity 100,000 times that of the optical star. So scientists at the time were wondering what kind of objects make X-ray sources. And this was clarified later on by the launch of Uru space satellite. It was the first X-ray satellite, and Uru discovered 500 X-ray sources from all types of objects, including binaries, is black hole or neutron star or white dwarf as a X-ray source. And then it became clear that phenomena of accretion by the compact object in a binary from the optical companion plays an important role and is a dominant process in binaries, AGNs, and other objects. So the URSC discovered a lot of the sources, and detailed studies of the sources were carried out by subsequent missions. Now my thoughts go back to this area, the 60s, when the X-ray astronomy was started at TR5 1967 with balloon-borne hard X-ray astronomy. Now so I got my thesis based on hard X-ray observations of SCO-X1, Cygnus X1, other sources. And subsequently, after getting my PhD in 1972, I got invitation to join Caltech as a member of a group which was having A2 experiment, UA2 experiment, of which Gordon Garmar from Caltech, Eliu Bolt from GSFC NASA, they were the principal investigator. So I had the great opportunity of working on a payload which was going to be developed, and so I had involvement, deep involvement in the mechanical design, in the electronics design, and so on. So actually, Professor Garma went on sabbatical leave. So 1 year, I was in charge of the experiment. And then there was a periodical review of 4 experiments which was conducted by Dr. Frank McDonald at different centers. So that review taught us how to critically look at the progress and deficiencies, overcome them. And I tried to adopt that same review process for AstroSat monitoring. So after the successful launch of UA2, the X-ray astronomy was placed on a firmer, way more secure basis, and then so then the astronomy, the UA2 followed by the experiments, they became. Now when I came back from Caltech in 75, I and Dr. Marar, who was in charge of the astronomy program at ISAC, we made a joint proposal to ISRO for X-ray astronomy satellite. Unfortunately, the launch vehicles at the time were not in a position to take a payload of about 50 kg or more to the orbit, near orbit. So then we had to wait till the 1995, 96, when PSLV became operational. So PSLV, we are very happy that PSLV first flight and second flight were both successful. And then ISRO has planned a remote sensing satellite called IRS-P3 for launch on the PSLV-3. So I approached Dr. Rao, who was the chairman of ISRO at the time, to give us the opportunity to fly on one of these IRS-P3 satellites. So then soon after Dr. Rangan became chairman, and Dr. Rangam himself has an interest in X-ray astronomy. He supported us. He told us that he will give, place to us to fly about 50-60 kg payload. And this instrument, this payload was based on proportion counters. So we flew this payload, later on we called it as Indian X-ray astronomy experiment, on the IRS-P3. Condition was that we should make the payload in 15 months. Can you think? Imagine making a payload 15 months for spaceflight. And we should qualify it, and then we should be ready by February for integration. It was a tall order, still it was a challenge, but still I accepted it, and then we worked with neck break speed and got the payload ready and delivered it in February. And then this was launched in March 1996. And we are very delighted when it went to orbit that we are getting useful data when you looked at Cygnus X1, SCO X1, and so on. So I think this is a milestone in development of access system in India. This is ISPC, this is IXA. This IXA was able to detect large number of sources, but we could observe only about 20, because one major handicap was that you can observe access sources only when you're not doing remote sensing observation in monsoon. So we used to get 2 to 3 years, months in a year when you could do observed sources. Nevertheless, we observed more than 20 sources, including most important source was GRS 1915 plus 10.5, which was a transient. And we were struck when during the course of 1 month observation, we saw Cauchy value burst, a period of about 50 days, and also QPOs. We reported this, and then I'm surprised that in 10 years later, the same observation, not from AstroSat, but from IST, was published by one of the US group. And when I asked them how come they did not refer to paper, they said they didn't know about it. And then same thing, Cauchy oscillation and 650 day periodicity was rediscovered, and it was given a fancy name of heartbeat of black hole. Okay? So this is now called heartbeat of black hole. Anyway, subsequent to that ISPC success, I thought of a bigger mission for access. So I wrote to Dr. Rangan that we would like to make a full-fledged access satellite. He replied back, he said that this is a good idea, but instead of doing that, but to do it, you should think of a broader vision. This is a satellite covering many wavelength bands. So meeting of astronomers occurred. It was discussed for the next 2 years, and finally the concept emerged that a niche area for AstroSat will be multi-wavelength observations. So we invited proposals. These proposals were reviewed, and finally 5 instruments were chosen, 3 from TIAFA, LXPC, SXT, and CZT. 1 from ISAC, URSC, and 1 from IIA, UVIT. You can see that, and these are led by 3 principal investigators, K.P. Singh for SXT, I think myself and Dr. Professor Manichandra for LXPC, and E. Tandon for UIT, and Dr. Rao for CZT. Okay, so this was history. So then in 2000, the research proposal was finally written by me, and then we submitted to Dr. TFR, who gave full-fledged support and promise for supporting it. And then finally, it was discussed by Chairman ISRO, approved, and then went to the Space Commission, and finally to Government of India, and we got clearance in 2000, October or something. And in 2000, October, Chairman ISRO gave us a go to develop instruments and provide budget. So I must say that I give a lot of credit to late Dr. Kasturirangan for supporting this. In fact, it would not have been possible without his support. So I remember him for this contribution. Now, TFR, as I mentioned, started the Bengaluru program in 1968, and which led to the development of balloon rocket instruments. Now, before I go So our experience in making the XPC, large area proportional counter balloon experiment, was a great, was appreciated, and we were confident that we can make large area proportional counter as we had made similar counters on balloon experiments and flown them successfully. Now, there are many new things which happen in AstroSat. There are many challenges in realizing the instruments which we had selected. The XPC, I was confident we can make, with a lot of experience in the proportional counter. And we had actually made something close to the XPC for balloons. Then soft X-ray, astronomy, soft X-ray detector, SXT, was based on use of paraboloid, hyperboloid, gold-coated foils, which are made in the shape of parabola, hyperboloid, and give you angular resolution of few arc minutes. So that was, I think, Dr. K.P. Singh, who took the responsibility and he delivered it. So I think it's a great achievement by Dr. Singh. We needed a CCD-based detector for SXT. We didn't have experience or capability of making in India. So we entered into collaboration with the University of Leicester, and who had experience on making CCD detectors for the new XM Newton. So that was successfully built and integrated with the optics developed by C60 group. And today, I must say, it is one of the 5 instruments on AstroSat which is working flawlessly with angular energy resolution far better than what we thought. The next payload was a CZT detector led by Professor Rao, which is a coded mask aperture. So idea was to localize the individual sources to better than 8 arc minute capacity and resolve them in the crowded region. It also has many challenges. One was to realize a low is the threshold of about 10 kV or better, and other was to do pixel to pixel calibration. So this payload was also successfully realized. But then we have UVIT, ultraviolet imaging telescope. Here progress was not, we were not happy with the progress. So we then brought in Professor S.N. Tandon, who is a great expert in all kinds of telescopes, to lead this group of UIT. And I must say that Professor Tandon and his team successfully realized UIT, and today UIT is one of the finest instruments working on AstroSat, although its one channel is lost. So you can see years of calibration, years of careful calibration, testing, they all were important in realizing its goal. So this learning in space instrumentation, progress often, depends on the launch capability. As I said, we had handicap that launch capability was available on PSLV only after 1995. Now I should remark here, and one more instrument which was developed was scanning sky monitor the time variability of X-ray sources. So this is one of the other instruments which contributed to the success of AstroSat. Now the question comes, what is next? After AstroSat, what can we do next? AstroSat, to me, is the outcome of nearly 5 decades spent learning, slowly and sometimes imperfectly, the making of instruments, creation of teams, and persistently staying with hard problems for years, learning from failures and respecting both engineers and discipline and other scientists. So what is the message for the young scientists? then I suggest that the young scientists should choose difficult problems, commit deeply, work closely with engineers, and build on the future missions. Keep the flag of Indian astronomy flying high, and my good wishes and blessing to you for the future missions. Thank you.
Professor P.C. Agarwal's enthusiasm for this conference was such that he readily accepted our invitation. Not only that, he insisted on having a presentation made. And late last night, around midnight, he sent an updated, corrected version to Anuj to have it presented here. And Anuj had to do all the background work for it. A big round of applause, please.
I once again thank Professor Agrawal for sharing those insightful anecdotes and your wealth of experience and guidance with us. Thank you, sir. I now invite Professor Dipankar Bhattacharya, Chairperson of Scientific Organizing Committee, who steered the scientific program of this conference. He's currently heading the Physics Department at Ashoka University and is well known for initiating GRV studies in India. We request you, sir, to take us through the scientific program of the conference.
Good morning. Dignitaries on the dais, ladies and gentlemen. It is my great pleasure and privilege to welcome you on behalf of the Scientific Organizing Committee to this three-day conference on a decade of AstroSat observations. AstroSat has been a truly versatile observatory, and it was always going to be a challenge to capture the diversity as well as scale of AstroSat achievements over the past 10 years in a three-day meeting like this. So we had a 15-member international scientific organizing committee, and we also enlisted the help of about 5 others. So the 20 of us worked quite hard together. We had 7 meetings to finalize the program, which you now hold in your hands. As you notice, that we have a few invited lectures. We divided the program into about 8 scientific themes, which you will see listed in the first page of the program. And we opened up for abstract submissions, and the response was overwhelming. So we constituted expert committees in each of these subject areas to pick papers for oral presentation and posters. And finally, we have 16 invited lectures. We have 80 contributor lectures, and we have 35 flash talks, and which has been packed into these 3 days. And we have 110 poster presentations. So it's really been a great celebration of science, and I welcome you to attend these sessions. And please do go through the posters. It's in the white box downstairs. The sessions are going to be held in this floor and a floor below. 2 halls are there, and this hall. So all the contributor lectures are going to be in parallel sessions, and the plenary lectures, the invited lectures, will be here. So welcome to you all. Look forward to the meeting. Thank you very much.
Thank you, Professor Dipankar, for providing us a bird's eye view of the scientific deliberations awaiting us. An event of this magnitude demands single-minded dedication and meticulous planning. It gives me great pleasure to invite Shri Jaswinder Singh Khoral, Chairperson of the Local Organizing Committee and Program Director, SCPO and UFPO at URSC, to share his insights into the tireless efforts that went into orchestrating this conference and bringing us all together today. Sir, we request you to kindly address the audience.
So AstroSat, which is the result of the sweat and ingenuity of countless scientists, engineers, and technicians across the nation, has now completed 10 years against its mission life plan of 5 years. And all this calls for a very memorable celebration of this historic occasion. So when we went with this proposal to our motivator-in-chief, Director URSC, Mr. Shankaran, he very readily agreed to this proposal and enabled everything and gave us the necessary guidance and inspiration. And then from there, we took it to headquarters where Chairman Dr. V. Narayanan, as you heard, he is not only a very ardent supporter of science and scientific missions, but also is very keen on science outreach. He very quickly gave his approval and all the necessary enablers with the headquarters and DOS and other ministries. And then began the race where within 3 months we had to have this call for papers, abstracts, set up the website and get the things going. And all this was done in a very short time thanks to the wonderful committee which I'm heading. There are 70 people spread across 7 subcommittees who have done extremely well. We searched high and low for a suitable location, and here we are today celebrating this memorable occasion. And we have, as you have already heard, an overwhelming response where we got 200 plus abstracts which were finally shortlisted out of the many more ones which we got, and 70 oral presentations followed by 100 posters, 3 parallel sessions. The SOC was very insistent on that, and that put a spanner in the works because the budget was very limited. But with all that, we are here today, and I thank all the members of the committee and Prashant, who was with me earlier, for making this happen. In brief, I want to just say one more thing. Some days back, I came to know that the word Hayat in Urdu means lived or long lived. And the person who told me this, he also said, Hayat as in Hotel Hayat. And I was like, serendipitous thing that we are having this occasion here at Hotel Hayat. So AstroSat is long lived. May AstroSat live long. Thank you all and have a wonderful time. If you have any issues, please feel to contact me or any of my team members. I apologize once again for any inconveniences caused to you. Well, have a nice time. Thank you.
Thank you, sir, for giving us a glimpse of the immense work that has gone behind this event. To document and record the rich scientific deliberations of this conference, the organizing committee has compiled the conference proceedings. I request Dr. S. Sita, Principal Investigator of AstroSat and Emeritus Scientist at Raman Research Institute, to kindly come forward and unveil this publication. I request all the dignitaries on the dais to join her for the unveiling, and I request Dr. V. Radhakrishna to please facilitate the release.
This is dedicated to all those who contributed to AstroSat.
Thank you, ma'am. Thank you, everyone. So the inaugural session has set the ball rolling to delve into the exciting realm of discoveries and results that AstroSat has brought into the scientific world. As this multi-wavelength satellite continues to serve the national and international astronomers beyond its intended lifespan, we look forward towards the mysteries it may unravel in future.